Right. Hey all. Today we are going to solve island treasure problem, aka walls and gate. So it is a um, spoiler alert. It's a graph problem, and we are going to solve this problem. So this will comes under BFS pattern. Like to be more specific, again a second spoiler alert. It's going to be multi-source BFS. Yeah, let's see, let's go through the question and we'll work out one example and we'll code it things up and we'll see how things goes. Right, you are given a m into n 2D array. So this is m into n 2D array, and yeah, 2D array grid initialized with three possible values. So they have given, like, they are initialized with three possible values. Let's see, like, what are those values. So they have given the -1 is nothing but water that cannot be traversed. Cool. So we have an sample image, the example image over here. Let's assume the water are nothing but the rock or blocker or wall, whatever. So it's a wall, so I can give -1, and the treasure chest are nothing but the gate itself. So these are nothing but zeros, the treasure chest are nothing but zeros, and the infinities are the land cells. So infinities are nothing but the empty land cells, which means this is infinity, infinity, and these are again infinity, infinity, infinity. Everything, the white space is nothing but infinity. Cool. Yeah, let's further read the question and let's see, like, what they are asking exactly. So fill each land cell with the distance to its nearest treasure chest, which means we need to start from, each and every land cell, and we need to check for, like, what is the nearest gate, and we need to update the distance. So in this case, starting from this position, I can go 1 2 3 and reach out to this place as 4. I can either, like, one possible way from this position, from this position is nothing but 4, and the other possible way, like, we have another gate over here, we can go 1 2 and 3, which is nothing but, like, with 3 steps we have the another gate. So the nearest one is nothing but the one in the south, which is 3. So we are going to have the values 3 over here. The same applies for each and every cell. Let's say from this cell we need to calculate the distance from the gates. We can have n number of gates, so we need to check all possible gates. Let's say if we have gate 3 over here, so we need to also find out what is the distance, and also we need to update the distance which is nearest to the gate. In this case, the nearest one is this one, so this is going to be 2. So how we can solve, instead of solving, like, from one gate, going through all the cells, we can do this way. We can start from both the gates, and simultaneously we can in a BFS level, layer by layer, we can proceed from each gate simultaneously. Yeah, I'm just repeating myself, sorry. And from this gate we are going to explore like this, and simultaneously we are going to explore like this. Again, this will go like this, and this will go like this, and again this will go like this, and from this gate it will go like this. It's more like in wildfire, like we are setting up a fire in a square, like in 2 different places, and it's just like fire up things in opposite directions. So yeah, I gave you a simple analogy, same way as, like, we are going to implement things. Before coding it up, I just want to walk through with this 2D grid. So we can start from this treasure chest as 1 and this treasure chest as 2, and from this place they have given, like, we can traverse top, bottom, left and right. So we are going to do the same thing, and from this place we are starting with 0 because zeros are nothing but our treasure chest. Fine. What I can do that, so when I go top, it's going out of bound, and when I go left it is a blocker, so I can't proceed with it. When I go bottom, it's a white space, and from this space, like, what's the distance to reach the chest is nothing but 1. And again, for this gate right hand side, it's a white space again, and the minimum distance to reach this chest is going to be 1 itself. So we are processed, so for the layer 1, we are processed this chest, and we need to process the layer 1 of this chest as well. So when I go left, it is out of bounds, and when I go right, it is a blocker. When I go bottom, it's out of bound again, so I'll go to the top, it's a white space. Yes, since it's a white space, I need to update the distance. So distance from this chest is going to be 1 itself. Okay, layer 1 of this chest been completed. We'll just work on the layer 2 of our previous gate. So far the values are nothing but, this one and this one. We'll try to process both of them. So as of now, we'll try to process this one, and from here we go to the top. It's already been visited, so we don't have to update it. From here we go to the left, it's a white space. So how we are going to update this part? This part is nothing but our current distance plus 1. So what is our current distance over here? Is nothing but 1 plus 1 is nothing but 2. So we are going to update the distance as 2, right? So distance as 2, and from this place again, the distance is going to be, from here it is going to be 2. So because we are going to the bottom, and when we go to the right, it's a blocker, so we can't proceed with that. And for this one, the 2 places are out of bounds, and the left one is visited, and the bottom one is blocker. So we are process the layer 1 of this gate. Now we process the we process the layer 2 of this gate, and we'll process the layer 2 of this gate again. So yeah, when we process the layer 2 of this gate, so when I go left, it's out of bound, right, it's a blocker, and bottom is visited. So the top one is a free space, which is the white space. We are going to update the value, which is the current value plus 1. So we are going to update as 2 over here, right? So for clear, I hope it's clear. And we are going to again go for the layer 3 of this gate. So layer 3 of this gate is nothing but this one and this one. As of now, for this position, the both top and bottom are blocked, and left and right are already visited, so we don't need to touch. So we'll start with this position. So when I go left, it is blocked, top it is visited, and the right one is blocked, and the bottom one is not visited. So we'll update the current distance plus 1 is nothing but 3. So we are done with the layer 3 of our first gate. Let's work on the layer 3 or level 3 of the second gate. So we previously just stopped with this one, so we'll start with this position itself. When I go to the left, it's out of bounds, right, it's already visited, bottom is already visited, and when I go to the top, it's not visited. So we'll just update with the current value plus 1, so which is going to be 3 over here. And still we left with layer 4 of the gate 1. So it goes left, blocked, bottom out of bound, top visited, and right it has empty space. So we are going to update the value 3 plus 1 over here is nothing but 4. Okay, let's go for the layer 4. Okay, 4 over here. Let's go for layer 4 of the gate 2. So far, like, it is out of bound, blocked, and visited. So yeah, we are successfully updated this grid. And yeah, so I have just declared the rows and columns, and I have declared the queue, and now we are iterating the grid to get all the treasure chest coordinates and put them into the queue. So queue dot append, we are going to have the row and column. So only if my grid of row and column is equal to 0, because zeros are nothing but our treasure chest over here. So I'll get a quick indentation over here as well. So See why grid is not defined. It's already been there, so no worries. So we can try implementing already. Yeah, everything looks fine. Yeah, now we can try implementing the BFS, which is the multi-source BFS. It takes nothing, and what we are going to have, so initially we have the queue, so we are going to start with while queue, run this loop till the queue is not empty. So once we run the queue, we are going to pop the element from the queue, the left element from the queue, and we are going to get the row and column from the queue. Yeah, once we get the the row and column, so what we are going to do is that we are going to try all 4 directions, and we need to declare the directions over here. Directions is equal to we are going to have the directions over here. The directions are nothing but 1, 0 and minus 1, 0 and 0, 1 and 0, minus 1. So yeah, so for dr, the direction, the and dc is nothing but my the column in directions list. And what I'm going to do is that I'm going to get the process the new row is going to be row plus dr, and I'm going to get the new column is going to be column plus dc, and we are going to skip the elements which are not we are looking for. So how we can do that? So we are going to have the condition if stating that minimum of the new row comma new column is less than 0, which means if the index get negative value, you should skip, or if the new row is greater than equal to the row itself, or the new column is greater than equal to the call itself, or basically if grid of we need to skip the new row and new column that is not equal to the infinity. So I'll have the infinity value. I'll copy and paste it over here. So for this value we are going to skip, and we are just looking for the values which are okay, we need to have the indentation, that's why. Yeah, no, it should fine, should be fine. Yep. So we are skipping on going negative index going negative values, and we are skipping if that goes out of bounds, and also we are skipping if the value is not infinity, which is the empty space or the white space. As soon as we find the white space, so what we are going to do, we are going to update the white space value. So grid of new row and new column is going to be grid of the previous row and the previous column plus 1. So this is going to be doing our job, because as soon as we get the BFS, it starts with 0, because this starts with 0 over here. Treasure just starts with 0. So 0 plus 1 in the first layer, 0 plus 1 is nothing but 1. So things will get updated in the layer. So we are updating that, and also we need to do one more thing. What is that? So we are skipping the elements, we are updating the values, and we need to append the queue dot append. We need to append the new possible new columns to the queue. So and things will get processed, and we don't have to return anything. It is none. We'll check once again, I guess, everything has been implemented. So initially the necessary things we have implemented over here, we are getting the dimension and stuff. We are creating an empty queue, and we are specifying all sort of directions. Once directions are specified, we are going through the grid, and we are cherry picking all the, you know, uh, all the treasure chests, because the treasure chest equal to 0, and we are doing the BFS. Once that's done, we are doing the BFS. So we don't have to do this thing, we can just directly go like this. Yeah, we can have like this. Sorry about that, the function declaration. So until the queue is empty, we are going to, okay, grab the elements, and we are going to try all possible directions, and we are going to skip the values which are like going out of bounds, or like which are getting negative values. And if the values are not infinity, once we skip those values, we left with the white space, or nothing but the infinity values that needs to be updated. So we are going to update based on the previous value, which is nothing which starts with zeros. Here we are updating, and once the update is done, we are going to add them to the queue, for the upcoming layers or level. So this thing is done, like it should work. So it has been accepted, and we can submit it now. Okay, this is not technically the day to forget about it, like I'm just revising. So yeah, this is it. And I forgot to mention the time complexity of this one. Since we are doing the multi-source BFS, like we are starting from all the gates simultaneously, so the total time complexity is going to be m into n, which is nothing but the size of the two dimension itself, and the space is going to be big of the total space complexity, because we are adding things to the queue. So it is going to be again m into n elements. So yeah, that's it for the video. Like if you have any questions, please drop the questions in the comment, and see you in the next video. Bye bye.